right? So we will try to rig up the circuit for this example. What we are taking is basically a monostable multivibrator driving a motor. Okay, so this is what we need to rig up. Okay, so now before starting, first thing is, if you see the schematic diagram, we require two power supplies. One is 12 volt supply, the other one is 5 volt supply. So the 5 volt supply is what drives the monostable circuit, and 12 volt is what drives the motor. Okay, now so this is the 12 volt supply what we have. Okay, and the 5 volt is generated by this module here. Okay, so this is a AC to DC converter module, okay, which basically generates the required 5 volts. And okay, it may not be very clearly visible. See these two pins here, okay, which I am connecting to the extreme connectors, or the 50 common track, okay, supply track. There I have both the positive and the negative. Okay, this side it is positive, okay, plus 5, and this is ground. Okay, so this is what we have. Okay, so these is where I get the plus or minus plus 5 volts. And this module I have configured, this power supply I have configured it to give out 12 volts. Okay, so this is what I have done. So first let me rig up the supply. So I require a 555 timer. Okay, so let me try to make the connection. Okay, so right, so now if you see this, okay, I have mounted the 555 IC. Okay, here there is a notch here. Okay, so that indicates the top position of the IC. Left of that is pin number 1. Okay, it will be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is of the ICs. So the requirement is pin number 5 is connected to ground. Pin number 7 and 6 are shorted to each other. Pin number 8 is connected to the supply voltage. Pin number 1 is grounded. Pin number 2 is the trigger pin. Okay, so if you see the way I have connected, I have a 10k resistor going to the supply connected to that point, and I have a switch. Okay, this is the push button switch. Pin number 4 is the reset pin, which has to be pulled high using a 10K resistor. Okay, then I need a 470K resistor, which is connected from pin number 7 to the supply. And the capacitor. Right. So I am assuming that I have done my connections properly. Okay, now I will try to see whether I get the output. Voltage ಬರುತ್ತಿದ್ದಿ no 12 volt what huh? Loose connection. Yeah. Okay. See, this is the first one. There is a loose connection here, so power was not coming, so I was not getting 5 volts. So this is what we have, right? Okay, so I have made my connection. Okay, so I have not added the transistor and the motor for the time being. I have just made the monostable connection. Okay, because divide and conquer. First I will see whether my monostable works, then I will go add the next circuit. Okay, so what is the expectation from the monostable? Pin number 3. Okay, how this should work? When I press the push button, okay, it should generate a 5-second pulse. That is what I am expecting. So output is seen at pin number 3. Okay, so now basically I am giving the voltage. Okay, the voltage is given to the circuit, but I don't see any pulse coming here, right? So you can see it in the scope, no change happening. Okay, so first thing is I will see whether the trigger is working or not. Okay, first thing is let me check the trigger. Okay, that is at pin number 2. Okay, pin number 2, I am supposed to get a high voltage, but there itself I am not getting a high value. Okay, so that means there is some problem in the connection. Connector.
Check whether it is the same.
Yeah, in this here.
No, it
Same,
is
same.
channel 2.
Channel 2. Yeah, I am seeing channel 2. Okay. So that means there is some issue in the circuits. Okay, so I need to debug. One thing I notice is I have not connected a ground to the circuit. So let me add that. Okay. And still I am getting at pin number 2, I am actually seeing a low voltage. Okay, I am expecting it to be high because it is pulled high. Okay, so I am expecting it to be pulled high. It is pulled high, so I am expecting it to have a high voltage. So that means there is some issue. So I need to check now whether I am giving the necessary voltage or not. So the voltage is doesn't seem to be there. At pin number 8 is the first place what I am going to check. No.
It is at 3.3 volt. Sorry, we have set it at 3 point, no?
No, I should either get no.
Getting 3.
I am not getting 3. I am not getting 5.
3.3 you are getting.
That is supposed to be here, right? That also is not there. What about that?
Channel 1.
That shouldn't matter.
No. Check the probe once.
That is fine. This probe is fine. తిరిగి సార్ ఓకే ಗ್ರೌಂಡು ಇದು ಗ್ರೌಂಡು ಇದು 3 ನನಗೆ 5 ಬೇಕು ಈಚೆ ತಿರುಗಿಸ್ಬೇಕಾ ಇದು ಹೇಳ್ತಾ ಉಂಟು ಸ್ವಲ್ಪ ಮುಂದೆ
Yes, now you check.
No, it is still the same. I am not getting voltage here. There is no voltage in the probe.
It's coming forward.
Hold barantiದ್ದು.
It's coming.
Then this no wire.
Check where this. No, this. Attenuation.
Probe wire. One more issue. Wire is not working properly. Okay. Nice. This is nice. Nice. So now I am getting 5 volts. Okay. So pin number 3. Output went high. It stays high and comes down. Okay. But the problem is I need to check whether it works for 5 seconds. Okay. So So now I have changed the timing scale of my CRO, so to get this complete pulse. Okay, so let me just stop it and see. So I am getting around 5.4 seconds. Okay, so 5 point. So you can see here the display B minus A value is 5.4 seconds. So now with the value whatever I have chosen, I am getting slightly more than what I want. Okay, I have written there as 5.6K, but I have actually used 470K resistor here. But still the value what I get is around 5.4 seconds. Okay, so this is what I am getting. That is because of the tolerances of the resistor. So I know now my monostable is working fine. Okay, so this is what I have. Okay, so next what I will do is I will connect the second half of the circuit, which is basically the transistor circuit. So let me just do that. Okay, so now I have added the transistor part as well. Okay, so this is where I have the transistor. So this is the collector lead, middle one is the base, and the end one is the emitter lead. Okay, so emitter I have connected to ground, collector to the motor, okay, to the 12 volt supply, and base is driven from the monostable circuit. Okay, so hopefully now it works. Okay, so right, yeah, works fine. Okay, so if it works fine, basically no job for debugger. Okay, so this is what we have. Now possible issues. Okay, so let me just do one try. Okay, so this is a 100 ohm resistor which was connected to the base. Okay, now instead of that I put a wrong component there. Okay, which is 470K. Okay, $470K. Okay, so now with the 470K, see I am giving a key press. So let me just probe that signal also. see the pulse has come but the motor doesn't turn on. What was the defect here? Wrong component put in. Okay, and why doesn't the motor turn on now? The pulse is still there. Can you guys guess why doesn't the motor turn on? Now to generate the necessary current for the motor, I need to give appropriate base current for the transistor. Now previously with a 100 ohm resistance, base current was in milliampere. So that is good enough to saturate the transistor. Now when I put a very large value resistor here, base current is not sufficient. Even though the supply voltage is there, you are giving around 5 volts, current is insufficient to turn on the motor. Okay, so circuit wise everything is fine. You are getting the waveform, but the circuit is not working as intended. Okay, so this is a fault now. Okay, so here we now have to see each and every point what is happening, or why, whether the voltage is there, still it is not coming. Then we have to debug that what is the reason for the current not coming. That is the base drive. So we have to now change the resistor. So this resistance is the culprit here. Okay, for this not working. Okay, so this is what it takes. Even though it is a very small circuit, normally works. Okay, because we have very few components here and generally it tends to work as intended. But there can be issues even with this component. Okay, even this component. See, one more example I'll give. I'll just remove this. This is a ground connection for the capacitors, timing capacitor. Okay, I'm removing that wire, indicating a open circuit there. Okay. So now my circuit look wise everything was fine, but there was an open circuit there. Okay, now I give a pulse. See, the pulse itself doesn't come. Okay, the pulse itself doesn't come. So in the same small circuits with 5 or 6 components, we can have many different faults. If the component is shorted, you will have one kind of fault. If it is open, you have one more kind of fault. If it is the wrong component, the behavior is different. So each and every part matters here. Okay, everything is fine, output is fine. Okay, so this is how it is. Is this, and I mean you have understood how the circuit, you have to make the connection and how to make it work. Now here we have done 2 parts actually. First thing is monostable we have connected, it works fine. It is working at a particular voltage and we have made the motor run because of the monostable. Second part, and if you see, I am working in 2 voltage domains now. One is the 5 volt domain, the other one is a 12 volt domain, and your timer is in a way isolated from 12 volt. Okay, not completely but to a certain extent, because timer just drives 5 volts to the base. Okay, and your base and collector are supposed to be reverse bias generally, so current will not flow in that path. Okay, so this is a simple way of converting from one voltage domain to another. If you want to drive a higher voltage, you can make use of transistors to do that to a certain extent, as long as you are okay with the connection between 2 voltage supplies. Okay, but one thing to notice, the grounds of both the supplies have to be made common. That is a requirement. 12 volt ground as well as your 5 volt supply ground, that has to be common, made common. Okay, so this is a requirement. And whenever you make the connection, ensure you give or you place the wires appropriately so that you have some room to rework on the component. So you have to remove certain component. You give enough gap so that you can rework. If you do a crisscross wiring, okay, it is always difficult. Even this wire is not apt for breadboard because it is, the length of the wire is large, so it will look like wire is coming out. Best thing is, if you have short wires, cut them as much as required and make the connection. That will make the circuit look neat. Okay, that will make the circuit look neat and debugging much simpler. Okay, and always, now in these wires they are color coded. Okay, so that is for you guys to have it easy for tracking. So if there is a color coded option, always go with it. You can easily track the wires. Okay, if you put normal tendencies, we will have at least 2 colors, black and red, and generally red is connected to supply, black is connected to reference. That is the general tendency. If you follow that, half of the problems are reduced because it becomes easy to track. Okay, and the third color one you can use it for the intermediate connections. Okay, so this is one practice. If you follow, it helps if you have to debug the circuit. Okay, so you need not remove everything and reconnect. Okay, so this is what we have. So let us again check whether the problem has rectified. Now here I have a problem because my resistor is large, so I will go back to my original resistance. Working fine. Okay. Now before stopping, I want to observe one waveform which is at the trigger point. Okay, which is at the trigger point, pin number 2. Okay. So this is how the behavior was. Trigger going low caused your output going high. Okay, so this is how the intended operation for the circuits. Right. So the blue colored channel is the trigger pin and yellow colored one is the output pin. Okay, so this is what we have. Fine. So any doubts in the session today? If you have any doubts, you are free to ask. Okay, if you have any doubts regarding any problems you have seen in the lab.